Well, good day, folk. And it's spring school, and it's time for mathematical literacy. So welcome, and let's see what we're doing today. Now, today what we're going to be concentrating on is a section called measurement. Now, measurement falls under our learning outcome 3. Okay, and part of that learning outcome is also maps, scale drawings, and scales. But we're not covering that today. Okay, all we're going to do is the actual measurement side of things. So let's have a look at the slide and see what we're doing. Guys, by the end of matric, I must be able to do the following. I must be able to convert different units. And I'm going to look at some problems that came up in the 2012 final paper. And you're going to see how we've got to be able to convert units. What do I mean by converting units? Converting millimeters to centimeters, centimeters to meters, and then also into kilometers. But not only that, we might be asked to convert or asked how many meters are in a yard. How many pounds are there in a kilogram? Okay, so it's not only converting units within our system, but it's also being able to convert units from our system into the overseas system. So we've got to know how to do all that. We've got to be able to use Pythagoras' equation for right-angled triangles. Guys, got to know how to do that. Okay, and I'm going to talk about that just a little bit later on. We've got to be able to use formula to calculate perimeter and area of 2D shapes. And then we've got to be able to use formula to calculate the surface area and volume of three-dimensional objects. Okay, now I said to you here that this whole thing of Pythagoras' theorem we're going to look at just very, very quickly. So let's do that. Here I've got a triangle on my page. Not just any triangle, it's actually a right-angled triangle. Can you see it here by angle B? We've got a little square at the bottom of our in our triangle, and that indicates that it's a right-angled triangle. What's a right-angled triangle? It's a triangle that has a 90-degree angle to it. Now, according to Pythagoras, if I took a square and I made a square, and I'm going to use a different color than white so you can see this. I drew a square on the line AB. Now, my lines aren't very straight, but you get the idea. In other words, the side of AB is the same length as all these other sides. Okay, it seems we've lost part of the line. There she is. If I were now to draw a square on the line BC, so we're going to draw another square here. So I know now that all these sides are the same length. And if I were to draw a square on line AC, so now, and I'm just going to put 2 here so you don't think that's the same length as AB, all these sides are going to be the same length. Let's make it easier for us to understand. I'm going to put numbers in. So I'm going to give this triangle some lengths. Let's say AB is 3 centimeters. BC is 4 centimeters, and AC is 5 centimeters. Now, when I look at the square, if I had to calculate the square on line AB, the area of that square, how do I calculate area? It's length times breadth. Now, my length is 3, my breadth is 3. What's the area of my little triangle? It is 9, because 3 times 3 is 9. Of my square on BC, 4 times 4 is 16. My square on line AC, 5 times 5 is 25. Now, I want to show you something, folks, because this is what Pythagoras is all about. Pythagoras is saying the square on AB plus the square on BC will give me the square on AC. Let's have a look. What is 9 plus 16? It's 25. Now, what's 25 minus 16? It's 9. And what's 25 minus 9? It's 16. In other words, folks, Pythagoras' theorem is saying this, that the square on AC is the same as the square on AB plus the square on BC. Or the square on BC is, how did we get the 16? We say 25 minus 9. So it's the square of AC minus the square on AB. And the square on AB is the square of AC minus the square on BC. And that's Pythagoras' theorem. Now, we're not going to have time today to do many examples of Pythagoras. In fact, we're not even going to be able to do one question on Pythagoras. But, folk, I want you to understand Pythagoras, and I want you to look in past papers and try and find questions that involve Pythagoras and see if you can solve it. Okay. And then, like I said, we've got to be able to calculate perimeter, we've got to calculate surface area, we've got to be able to calculate volume, we've got to be able to calculate actual area of shapes as well. Now, there's one golden rule. In fact, there are two golden rules that I have. The first rule is this, folk. With this section in mathematics, you will be given formulas. And if the examiner gives you a formula, you must use that formula. It's no good getting given formulas and you look at your question paper. In fact, I have a question paper here. So you look at your question paper, you see these formulas and you never use them. That makes no sense whatsoever. If the examiner gives you a formula, use the formula. And the great thing about this section is your formulas are always given to you. And that's exciting because those formulas help me plan how I'm going to answer that question. My next rule is this. Guys, my units must be the same if I'm doing this section. In other words, if I give you a triangle, and I ask you to calculate the area of that triangle, I can't have a triangle where I've got the height in millimeters and the base in centimeters. If I give you a rectangle, I can't give you the length in meters and the breadth in millimeters. Well, I can give it to you, but you can't use it like that. So you've got to change the units. You can never add units that are different. You can never multiply units that are different. You can never subtract units that are different. And you can never divide units that are different. What am I saying to you? I'm saying to you, your unit must be the same. If they're not, don't even try and answer these questions until you make them the same. Okay? Time to move on. Let's have a look at our very first question. Right. And I love this question. I'll tell you why I love this question. Because I just love aeroplanes. I find aeroplanes absolutely fascinating. I don't know how this big piece of metal stays up in the air. It boggles my mind. Okay? Because when I put a piece of metal in the air and let it go, it comes crashing to the ground. But for some reason, aeroplanes stay in the air. And your science teachers will know why. So let's have a look at this question. A local airline company uses 3 types of aircraft for its domestic and international flights, namely Jetstreams, Sukhois, and Avros. Below is a picture of the Jetstream aircraft, as well as a table showing information on the 3 types of aircraft. Okay. So we've got 3 aircrafts that this particular airline uses. And they're really strange names. The names aren't important. The fact is, they're 3 different types. And those 3 different types have different bits of information about them, or different statistics. So let's have a look at here. Let's look here at our Jetstream. Our Jetstream, we're told, can only have 29 passengers on the train. On the plane, rather. We're not on a train, we're on a plane. The Avro, though, can have 83 people on the plane. So straight away, we know that the Avro plane is a lot bigger than our Jetstream. The length of the plane, so from the front all the way through to the back, is 29.25 meters. The wingspan. And now I want you to take notice of something, because examiners tend to do this, and they can do it. They've got every right to. So you've got to be able to understand how to read this table. Look at this funny little star here. So it's got wingspan and there's a star. What's a star mean? Well, let's have a look here at the bottom of the table. There's another star. So what it's saying is wingspan. Let's explain to you what the wingspan is. And so the examiner is quite nice about it. So he says wingspan, star, look for the star and you'll know what the wingspan is. We look for the star at the bottom and it says it is the distance from the tip of the left wing to the tip of the right wing. Okay? Now we know what wingspan is. Look at it again. It does the same thing with fuel capacity. This time it gives us two little stars. What does two little stars mean? Two little stars mean it's the mass of the fuel in the tank. That's what fuel capacity actually means. What does maximum operating altitude mean? Well, there are three stars. It means the recommended maximum height that the aircraft should fly at for the best fuel efficiency. It's not telling you it's got to fly at that height. It's saying, guys, that's the best altitude. If you want to use the least amount of fuel and get the best performance out of your plane, then that's the height you should be flying. So for example, for our little jet stream, the best operating altitude is 25,000 feet. Now I know what you're thinking. You're sitting there thinking, feet? What's a feet? Or what's a foot? Okay? We're going to look at that. Now, maximum cruising speed. We've now got four little stars, and four little stars mean the maximum average speed that the aircraft flies at its maximum height. Okay, so we've looked at our table. There's a whole lot of information. Look at this table again. A whack of information. You look at it, you get kind of dizzy. Don't panic, because questions are going to direct you to a specific place in the table. So when you get asked a question, you don't have to look at all the information. You can source this information is what I'm looking at now. Let's have a look at a good type of question. Here we go. A nautical mile is a unit of measurement based on the circumference of the earth. Now, 1 nautical mile is equal to 1,1507 miles, which is also equal to 6,076 feet, which is also equal to 1,852 kilometers. Sure. So now this examiner is saying, we're going to give you some information whereby you can take a nautical mile, compare it to normal miles, okay, that they use in England and America, compare it to feet, and compare it to kilometers. Well, thank goodness they've included kilometers, because I don't know what a mile is, a foot is, or a nautical mile. Well, that's what you're thinking anyway, okay? Now, how does the question go? Here we go. Calculate the maximum operating altitude to the nearest nautical mile of the jet stream. Guys, and this just doesn't apply for just this section. Hey? It applies for every section in Maths Lit. At the end of every question, ask yourself, how many decimal places must I round to? So if you get an answer and it's a number, comma, something, 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 say to yourself, myself, there are a lot of comma, something, 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 somethings here. We got to round that number. Okay? So whenever you get a weird answer, always say, oi, what must I round to? Okay? And if the question doesn't tell you, then you're going to round to 2 decimal places. Why? Because in front of my exam paper, the very front page, it will say, unless otherwise stated, round all answers to 2 decimal places. Okay? However, in this question, they're telling you how to round. How do we have to round? We got to round to the nearest nautical mile. Okay, so what we're going to look at now, and I'm going to use a different color so you can see this. We're going to look at this. Calculate the maximum operating altitude of a jet stream. So let's go back to our table. We want the jet stream. Let's get rid of all this other rubbish that I've circled and ticked here so we can see exactly what we're doing. We want to look at a jet stream. So my information is coming from this column over here, the jet stream. Okay, that's the aircraft I'm looking at. I'm not interested in the other two aircrafts, only that jet stream. But I'm not interested in all the information about the jet stream. What am I interested in? Look here, the question says the maximum operating altitude. So where's the maximum operating altitude? Here it is here. So what am I focusing on? Guys, let's do this in a different color. Here we go. I'm worried about this. In fact, I didn't even choose a different color. There we go. I'm worried about this 25,000 feet. So I've got to take 25,000 feet and change it to nautical miles. Okay, so this is what I'm going to write. I'm going to write that 1 nautical mile, and that's a horrible word to spell, isn't it? Nautical mile is equal to how many feet? 6,076 feet. Right. But I don't want to know about 6,076 feet. I want to know how high is 25,000 feet. So we want 25,000 feet. Right. You'll notice from my board, I've got miles in one column and I've got feet in the other. Everything to do with miles, nautical miles, is going down my one column. Everything to do with feet is going down my other column, keeping the nautical miles separate from the feet. And guys, in that way, I'm not going to get confused. The next thing I've got to do is this. I know what 6,076 feet is equal to. It's equal to 1 nautical mile. The question asked me for 25,000 feet. Now, before I can work out 25,000, I've got to be able to work out 1 foot. And gentlemen and ladies out there, 1 is a magic number. I always say to my students, when you don't know where to go, go to the basic number 1. Look here. We're going to say 1 foot. Okay, we got lots of feet and we got 1 foot. There it is. Now, how did I change, and I'm going to use this color, white now, 6,076 feet to 1 foot? I divided it, didn't I? I divided it by 6,076. So I'm going to do the exact same thing under the nautical miles. What's good for one is good for the other. So I've got 1 and I'm dividing it by 6,076. Now, how do I get this 1 foot to become 25,000? I multiply by 25,000. 1 times 25,000 gives me 25,000. So what I do on the one side, I'm going to do on the other side. So we've got 1 over 6,076. I'm taking it across and I'm saying, right, on this side, on my feet I times by 25,000, I'm going to do the same under the nautical miles. So 1 over 6,076 times 25,000. Now guys, this brain in here is a little bit small. Doesn't work properly. It needs a calculator. And that's what I'm going to bring up right now. So we bring up our calculator and I say, right, fraction button. 1 over 6,076 multiplied by 25,000. Equals, and there's my answer there, 4,11 something. So let's write it here. 4, let's try write it again. 4,11 something 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 nautical miles. Now, remember what I told you? I've got this horrible number. 4, something 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 something. round to the nearest nautical mile. So my answer is 4 nautical miles. Jeez, we really started off with a tough question here, guys. We really did. Let's get on to our next one quickly. Our next question, still to do with the aeroplane, says this. Mrs. Bovey traveled in an aircraft that covered a distance of 510 kilometers in 39 minutes. Determine, showing all calculations, so it's telling us show your calculations, in which one of the 3 aircraft she could have been traveling. Now the following formula may be used. Oh, I love it when examiners say, hey, you might need to use this. Because what they're indirectly saying is, hey, you've got to use it. And that's what we're going to do. Okay, so what's our formula? Our formula is distance is equal to my cruising speed multiplied by my time. And we are trying to find out what is the speed that this aircraft traveled in. Right? So, how far did she travel? She traveled 510 kilometers. Oops. 510 kilometers. And the speed at which she traveled, we have no idea. That's the question. But we know she did it in a time of 39 minutes. So we've got to calculate the speed. Now, if I say to you, how fast did your dad travel on the freeway? You're going to say, yes, like, he traveled fast, eh? He traveled 120 kilometers per hour. You're not going to say he traveled 120 kilometers per minute. No, no. We deal with kilometers per hour. But look at my problem here. I've got 39 minutes. In other words, I've got a problem because my speed has got to be in kilometers per hour. And I'm going to look at it as kilometers per minute, which is just not going to work. So, speed is equal to what? It's going to be 510 kilometers divided by 39 minutes. Now, folk, how do I change minutes into hours? Okay, we're dealing in minutes, we've got to change it to hours. How do I change minutes to hours? I divide by 60. So I'm going to say, listen guys, it's 510 kilometers, not divided by 39, but divided by 39 over 60. And it's now no longer minutes, but it's now hours. Okay, so what is my speed? Well, out comes my calculator again. And we're going to say, right, fraction button. We got 510 over, and we got another fraction at the bottom there, 39 over 60. And our speed now is going to be, look at that, 784,62. 784,62 what? Kilometers per hour. Sure, so we've answered the question. No, we haven't answered the question because the question was determine which one of the aircraft she could have been traveling in. So we know she's traveling 784 kilometers an hour. Let's go look at our cruising speed. Okay, we've got 500 kilometers. Let's use a different color because white on white doesn't look good. 500 kilometers. We got 800 kilometers and we got 784 kilometers. That's our maximum cruising speed. Guys, if she averaged 784, which aircraft do you think she's in? Well, you could look at that and say, I think she's in this aircraft over here, the Sukhoi. Or you could say, I think she could be in the Avro because she's traveling at a cruising speed of 780. 784, and the maximum cruising speed is 780. Well, that doesn't make sense then, does it? Because if you're saying the maximum cruising speed is 780, why would they have cruised at 784 kilometers? Well, maybe the wind was behind her, behind the plane, and it kind of made it go a little bit faster. That could be, okay? But to play it safe, I would probably have said it's the Sukhoi aircraft. Why? Because it's traveling at 800 kilometers an hour. So if you're averaging 784, it's still just under that 800. That's probably the safest route to go. All right. My goodness, we've really started this off on such a high note. I mean, we're not even giving you paper one type questions here. We're just going straight for the jugular and giving you paper two. And there's some tough stuff here, folk. There really, really is. Let's have a look at another quick question. Okay. It says here, determine the fuel capacity to the nearest litre of the Avro aircraft. So again, guys, let's take note. We're only looking at the Avro aircraft. And what we want to look at is the fuel capacity. So we're looking at the fuel capacity. So that's the figure we're looking at. So there's a whack of information, but we don't have to look at it all, just at that one. Now we're going to fill in all the missing bits. So we've got our fuel capacity, and we tell you when the aircraft's full of fuel, the fuel is going to weigh 9,362 kilograms. And someone says, yeah, but you know what, we don't put in petrol by the kilogram. We put it in by the litre. So how many litres do I have to put into your aeroplane? Well, here we go. If we look at this, we're going to say, right, my fuel capacity in kilograms, and remember it was 9,362 kilograms over 820 grams. Now, folk, I have a huge problem with that question. Why? Because right in the beginning of this program, I said to you 2 golden rules. Okay? Number 1, use the formula given, which I've done. Number 2, you cannot do any calculation in measurement if you've got different units. Look here. I've got kilograms over here and I've got grams over here. That is problematic. So I'm going to change all of it either to grams or to kilograms. But I'm going to leave it in kilograms. So we've got 9,302 kilograms over 820 grams, but I'm changing the grams to kilograms. Now, how many grams in a kilogram? You should know this by now, grade 12. 1,000, hey? So I'm going to divide that by 1,000, and I'm going to land up now with 9,362 kilograms divided by 0.82 kilograms. Now I can do this with my calculator. So 9,362 divided by, what are we dividing by? 0.82. Divided by 0.82, and we get an answer now of 11,417. 11,417 liters. Does it tell us how we've got around? It doesn't. It does. It says to the nearest litre, and that's what I've done. So my answer is 11,417 litres. So when the pilot says to me, let's pretend I'm the guy putting the petrol in the aeroplane, and he says to me, hey, I need 9,362 kilograms. I'm going to say, just a minute. Oh, yeah, that's 11,417 litres. Right, boss, you got it, and I'm going to pour it in. And on that note, we're going to take a break, and we'll come back and look at another type of question. Well, welcome back from the ad break, folk. We're busy with mathematical literacy, and we're busy looking at the section of measurement. And what we're doing is we're taking a few questions from the 2012 government paper, and we're looking at how we can answer those questions, all right? And each one of them are to do with measurement. And remember, just before the ad break, we had a wonderful question about aircraft, and there was so much conversion we had to do. Okay? Now, let's have a look at this next question. This is from the paper 2, November 2012 paper, and in their paper it was question 2.3. We're just going to call it question 2. Let's go for it. Danny bought a braai drum to cater for those customers who wanted grilled meat. The braai drum is made by cutting a cylindrical drum in half and placing it on a stand, as shown in the picture below. Okay, so guys, you can have a look at this drum. You see this drum, and you know what that drum looks like. I'm sure you've seen them. So you get these wonderful, huge oil drums. And to make a braai out of them, once they've been used, we take them and we cut them down the middle. And then we've got two halves, and each half folds out, and we've got a braai drum over here and a braai drum over there, and that's exactly what it looks like. Okay, so when you look at this picture, you can see the drum, but it's not standing up, it's lying down. Okay, and because it's lying down, please understand something. What this examiner's done is said this: we have this drum, this is the height. We're now taking it, we've cut it in half, and we're lying it down. And that's why he's calling this the height. Do you see in the diagram? He's saying the height is what we would normally call the length. But the reason why he's called it the height is because the length, when it stands up, it's actually the height of the drum. Do we understand that? Got to understand the concept, because this question gets quite confusing. So let's go for it. Now, the semi-cylindrical braai drum has a diameter of 572 millimeters and a volume of 108 liters. A rectangular metal grid with dimensions 1% greater than the dimensions of the braai drum is fitted on top. Let's go back to our diagram. If you look at our diagram, you can see there quite clearly that we have the actual drum. On top of the drum is this funny kind of wire thing which we call a grid. And obviously that grid is what we put our meat on. Now folks, if the grid is smaller than the braai drum, the grid's going to fall down, clearly. So we don't want that. Okay? We want the grid slightly bigger than the drum so it fits on top of the drum. I think that makes sense. Yeah? How much bigger is it? It's 1% bigger. And that, I bet, is a question which we're going to look at just now. So, we're told that H represents the height, D is the diameter of the drum. Okay? Here's another little thing. I don't like this word at all. And that's the word diameter. I hate the word diameter, right? I detest the word diameter. In fact, I say to my students, diameter is like a swear word in my classroom. I don't want to hear it. Whenever I see the word diameter, I cross it out. And I'm going to say not diameter, but rather radius. Why? Because radius comes up so often in our formula. Okay? Diameter does too, but not as much as radius. So when I'm told here that I have a diameter, look at this, diameter of 572 millimeters. So I'm told my diameter is 500, oops, let's get this pen going here, equals 572 millimeters. My students will straight away say, oh, we're not allowed to use that D word. Let's change it to radius. How do I calculate the radius, chaps? Radius is half the diameter, isn't it? Let's have a look here. Let's say if I were to draw it over here. I'm going to go right to the bottom of this page. Here I've got a circle. My radius is from the center of the circle to the circumference of the circle. In other words, from the center of the circle to the outside of the circle. That's my radius. My diameter is from one side of the circle to the other side of the circle, going through the center of the circle. So were I to draw a line like this, I could say this whole line, okay, let's use a different color so you can see it. This whole line here is called my diameter. And you can see it's made of a radius and another radius. So two radii make one diameter. So when I go back over here and I look at this, if I know the diameter is 572 millimeters, what's the radius? Must be half a diameter. So out comes my calculator and I say, right, 572 was that horrible D word, divided by 2 and I get my radius of 286. So I've got 286 millimeters. That's my radius. I never want to hear about the D word. Okay, so we now told this. The area of a rectangle is equal to length times breadth. That's one fact we told. We're also told that 1 liter is equal to 1,000,000 millimeters cubed, or is also equal to 0.001 meter cubed. Okay? So, Danny filled a third of the base of the drum with sand. Give 2 practical reasons why sand was placed in the Braai drum. That's an interesting question, isn't it? So I've got this Braai drum, and I'm filling it with a third of the volume of it is filled with sand. Why do we fill it with sand? Well, there are a number of reasons. The examiner only asks for 2. Let's think about it. Guys, first of all, if I put sand in the bottom of the drum, I'm weighing that drum down. It's not going to go falling all over the place. Secondly, by putting sand in, I'm raising the level of the coals that are going to go on the sand. So it's going to be closer to my grid, and so I don't need so many coals to braai the meat. Also, when I put charcoal in the bottom part of my drum, I've got to use quite a bit of charcoal to fill that up. But if I put sand on, because it's closer, okay, and because it's not that horrible round shape, I'm going to use less coals as well. And then another reason, which I suppose you could say, it's always good to make a fire on some sand, okay? Just kind of safe, right? So if something goes wrong, well, the sand's you got a bit of sand there just to sort out any major problems. All right. So we've thought of a number of reasons. I'm sure you can even think of more reasons. The examiner said, hey, only 1, 2, so only give him 2. Okay? If you think, geez, I'm clever, I know 22, and you write all 22 down, you know what, guys, the sad thing is they're only going to mark the 2 anyway. Okay, so don't waste your time. Next one, calculate the volume of sand used. Now, let's have a look at this. We're told, and I circled the important things, we have a volume of 108 liters. So the drum can take 108 liters worth of liquid or sand or whatever it is. The sand, though, only takes a third of it. So we're going to say, right, we only want a third of that. So 180 times a third. Or we could actually say, what about us saying 180 divided by 3? Same thing, folk. So out comes our calculator, and we're going to say, right, we've got 108, we're dividing it by 3 because we only want a third, and we get 36 liters. So I've got 36 liters of sand in my drum. And that's a third. So if I got 36 and another 36 and another 36, those 3 36s should make 108. Okay. Now, my next question is on the next page. Let's have a look. It says here, calculate the length in millimeters. So the examiner is clearly saying to us, look, I don't want it in meters. I don't want it in liters. I don't want it in centimeters. I want the answer in millimeters. And because I want the answer in millimeters, you better give it to me. So calculate the length in millimeters of the metal grid. Now, folk, if we look at the metal grid, remember we discussed this, the length of the metal grid is exactly the same as the height of that drum. So the length of the grid has got to be the same thing as the height of the drum. So let's have a look at that. But what we're going to say is this. We were given this formula. And the formula says area of a cylinder. We haven't used it. Let's use this. We're going to say volume is equal to, and it gives it to us very clearly, pi times r squared times the height. Okay. Now, I know that pi is 3,14. How do I know that? Because the question tells me that. And I know the radius. What is the radius? Remember we worked it out in that previous question when I had absolute horror because we were looking at diameter. The radius was 286 millimeters. So I've got 286 millimeters. I've got to square that. Oh, and matrics always forget to square that in an exam. Times the height. And that's what I've got to find. But if I've got to find height, surely I've got to know volume. Because in any equation that you get given, folk, if you've got to use it, or if you're going to use it, which you should if they give it to you, you can only have one thing that you don't know. So I don't know the height, so do I know the volume? Well, I know that the volume was 108 liters. So let's write that down here. I've got 108 liters. I'm also given this. I'm told 1 liter is equal to 1,000,000 millimeter cubed. Let's do that. I've got liters aside and I've got millimeters aside. Okay? Or millimeters cubed aside. I know that 1 liter, let's get rid of the 108, I know that 1 liter is equal to 1,000,000 millimeters cubed. What's a millimeter cube? It means if I get a little box and it's 1 millimeter long, by 1 millimeter wide, by 1 millimeter high, I've got to have 1,000,000 of those things. If I fill up 1,000,000 of those tiny boxes, I'll have a liter of water. Okay? I don't want to know what 1 liter is. I want to know what's 108 liters. So we're going to go down here and say 108 liters. How did I get this one to become 108? Multiplied by 108. What am I going to do this side? I'm going to multiply by 108. And folk, 1,000,000 times 108 is going to give me 108 million millimeters cubed. So I know that my volume is 108 million millimeters cubed. Okay. So what have I got? I've now got 108 million, 1, 2, 3, 4, 5, 6 noughts, millimeters cubed is equal to, I'm going to do my 3,14 times my 2,86 on my calculator. So let's do this. 3.14 multiplied by 286 squared. Remember, it was squared. Look at that. Okay, let's look at that. Remember that. So we have squared it on our calculator. Equals, and I now land up with an answer of 256,839,44. Am I going to round that? Not yet. I'm only going to round the final answer. So now I've got to remember this. 256,839. So let's write that. 256,829, was it? 839.44. 839,44 millimeters squared times height. Now I want height. What am I going to do? I'm going to take that 108 million millimeters and divide it by the 256,839,44 millimeters. So let's do that on our calculator straight away. We're going to say, cool, we got 108 million, 1, 2, 3, 4, 5, 6. We're dividing it by 256,839.44 millimeters squared equals, and I get an answer of 420,496, whatever. The question says round to the nearest millimeter. So I've got 420. So my answer now is 420 millimeters. But folk, what have I calculated? I've calculated this drum, haven't I? Remember we did it on the other page? We've calculated the height of this drum. There's the drum. We've calculated that height. That height represents the length of my grid. But I must remember to add 1%. Why? Because the question says that the dimensions are 1% greater than the drum. And remember, we said it's got to be greater than the drum, otherwise it's going to fall into the drum. So we want the grid on top of the drum. So here we've got an answer now of 420 millimeters being the height. Now what I'm going to do is just rub some of this out. There we go. So I can carry on writing at the bottom here. Okay, so we got 420 millimeters as the height. So the length, therefore, the length of the grid is going to be the 420 millimeters plus 1%, and you know 1% means 1 over 100, of that 420 millimeters. So let's do that on our calculator. We're going to say I've got 420 plus 1% of 420 equals, and my answer now works out to 424,2, or 420, what is it? 424. Why only 424 millimeters? Because again, folk, the question did tell us calculate the length in millimeters of the actual grid. And that's what I've got, 424 millimeters. Right, I think we've got time for another question. Let's do it. Question 3. To reduce her electricity bill, Mrs. Ntanzi decides to install a solar geyser on the roof of her house. The solar geyser consists of a rectangular solar panel and a cylindrical storage tank, as shown in the diagram below. All right, so let's have a look here. We've got our house. On top of our house, we have this geyser. Okay, and in order to keep this geyser, the water in the geyser warm, instead of putting an element in which case we've got to use a lot of electricity, what they've decided to do is put solar panels on the roof. And the way those solar panels work is the sunshine shines on the panels, the water goes through those panels. Because the sun's on the panel, it warms that water up, and that water goes into the geyser. So it keeps that water in that geyser nice and warm. Okay, so the solar panels use sunlight to heat the water stored in the cylindrical tank. The heated water can be used in the house. There are altogether 6 people in Mrs. Ntanzi's household. Now guys, why have they told us there's 6 people? They've probably told us that because we need that information. So let's remember that. You'll see I've circled my important information here. So here we have solar panels. We've worked out the length. And remember, solar panels, not just one panel, folk. There are a whole lot of panels, and they're all next to each other. Okay? So there's the solar panels. the length is the amount of panels we're going to need, and then the breadth, we told each solar panel has a breadth of 1,5 meters. Here's our geyser, and it's a hot water tank. It's got a length, and obviously, folk, this thing as well has a radius. Okay. Now, you may use the following formula. Again, I've got to smile when I see that, folk, because when I see that the examiner's saying, you may use this, he means you better use it. Okay, so you may use the following, that the area of a rectangle is length times breadth. The volume of a cylinder is pi times r squared times h. Now, Mrs. Ntanzi was told that she needed solar panels with an area of 2 meters squared for the first 2 members in her household, and thereafter an additional area of 0.7 meters squared for each additional member. Right. The question is, determine the total length of the solar panels needed by Mrs. Ntanzi if the breadth is 1,5 meters. Okay, so we want to know what is this length. In other words, how many solar panels do we need? So let's have a look. In our household, remember, she has one person, plus person number 2, plus person number 3, plus person number 4, plus person number 5, and person number 6. We told the first 2 people need 2 meters squared of paneling. Okay, so they need 2 meters squared. Thereafter, every person needs 0.7. So person number 1 and person number 2 need 2 meters squared. If they were just 2 people in the house, that's all the paneling we'd need, 2 meters squared of panel. But we don't need that. We've got more people, so we need more area of panels. Now, person 1 and 2 share 2 meters squared. Person number 3 needs 0.7 meters squared. Person number 4 needs 0.7 meters squared. Person number 5 needs 0.7 meters squared. And person number 6 needs 0.7 meters squared. So what does all that add up to? Well, our calculator is going to do that for us. It's going to say 2 plus, so that's person 1 and 2. We need 0.7 plus 0.7 for person number 4 plus 0.7 for person number 1, 2, 3, 4, 5, and finally 0.7 for person number 6. Gives me a total of 4,8. So I need an area of 4,8 meters squared. So this area of panel, the whole area here, must be 4,8 meters squared. Now that's not the question, hey? The question is, what length must those solar panels be? Now, this is where I get excited, because this is where we look at this formula. Area of a rectangle is length times breadth. So let's have a look at this. Area equals length times breadth. I know the area of my panels. It must be 4,8 meters squared. Do I know the length? No, I don't. That's what I've got to find out. Do I know the breadth? Absolutely. I'm told it's 1,5 meters. And it also shows that on my diagram. So I've got 1,5 meters. So now I've got to find length. Folk, what's the sign between length and my breadth? It's times. So when I take that 1,5 meters squared, how do I get the length by itself? I'm going to say 4,8 meters squared divided by 1,5 meters, and that's going to give me my length. So my calculator is going to do that. It's going to say 4.8 meters squared divided by 1.5 meters equals 16 over 5, which is 3,2 meters. 3 comma 2 meters. And that is my length, right? Because that's the question that was asked. Now, what I say to my guys at school is this. Listen, chaps, and I call them chaps because they're all guys, all right? If I taught boys and girls, I'd say, hey, listen, guys and girls, but they're not. Okay, so I'd say, listen, chaps, let's see if our answer makes any sense. How do we determine if our answer makes sense? Well, we know what the breadth is. We're told area must be length times breadth. If our area is 3,2 and our breadth is 1,5, what's our area going to be? Well, let's do that on the calculator. 3.2 times 1.5 equals, and guys, there's my answer, 4.8, and we were told the area must equal 4.8 meters squared. Sure. This has been a tough session, folk. We've gone through some really, really difficult problems. But guys, if you want to get 80% at the end of the year, if you want to achieve a level 7 at the end of the year, these are the type of questions that are going to determine whether you're going to get there or not. So my advice to you is, let's get hold of as many past papers as we possibly can and work through them. Sit with a group of friends and let's say, guys, let's tackle this question today. And you work together and try and do it. Why? Because if you can answer every question in your past papers, your 2008 paper, your 2009, 2010, 2011, and last year's paper, I want to tell you something, 2013 is not going to be that difficult for you if you can do all those other questions. So what are you waiting for? Phone a friend, get hold of them and say, come on now, we got to do some work. And on that note, I'm going to leave you, say cheers, and I'm sure we'll see each other on the screen again shortly. Cheers.